Welcome to a lesson with Dr. Powell. Now, talking about continuous functions or operations. Now, there are something that we're not going to talk about in this class very much, but what if you were to put in an ordered pair as a point of a domain and you output something? This is often the case of a relief map or something, or kind of a description where you have mountains or something or valleys or whatnot, and let your xy be a coordinate point. And then the output is maybe the altitude. What's the altitude at that xy coordinate point? That's a well-defined function from a coordinate point to an altitude. So the elements of the domain are simply just pairs. Now, if you think about that, actually, and if you were go on some Desmos or some other calculator that does 3 dimensions, and you had something like this, x plus y, you'd notice a nice smooth surface, even a plane, something that's a continuous version of something 2-dimensional. Likewise, for subtraction, multiplication, and even division where it's defined. All of these are continuous type of operations, meaning that limits can pass in and out of them very nicely. Taking a limit's the same as plugging in to both the things, to both components, perhaps, of the input. So, for instance, what if I had the limit of one function plus another function as x goes to something? Then this limit, it splits very nicely. X goes to 7 of f of x plus limit as x goes to 7 of g of x. Very nice splitting involved. The same thing would happen if I changed this plus to multiplication or division even, or subtraction. It would work the exact same way for that very purpose. So we have some basic things that we can always do with limits. Limits can pass in and out of continuous type operations very nicely, and it passes across pluses, multiplication times. Essentially, using that idea, you can do almost all your limit computations just by using that. Thanks for watching.